Hi guys, welcome back to Math 100. Today we are doing an exam 3 review. And for today's review, we're actually just using an old exam. So this is literally one of the exams that I gave in a previous semester. I know it says exam, but we're just using it as a review. So let's just say exam 3 review. Or you can say, what's the name? It's the key. Okay, here we go. So, number one. So Sanji wins 5 out of 11 bouts with Zoro. What are the odds in favor of Sanji winning a particular bout? So whenever you see these odds questions, my recommendation is actually just start with S, F, and T. And this actually applies whichever direction you're going. I think I may have shown you a little bit different way before, but really, I think the easiest way to go about these kind of questions, anything involving odds, is to figure out what is your S, F, and T first. And if your probability is given as a decimal, just change it to a fraction first, and then do the same thing, figure out your S and T. In this case, it says Sanji wins 5 out of 11. That means altogether there's 11 bouts. That means the T is 11, and he wins 5 of them, so the S is 5. Which makes the F then 6, because 5 plus 6 is 11. Now, what are odds in favor? Remember, odds in favor are always given S versus F. So in this case, that's going to be 5 to 6. That's the odds in favor of him winning. What about odds against? You just reverse the order. F to S instead, which would be 6 to 5. And that's it. That's the answer. I like, yeah, no, that's fine. Sorry. 6 to 5 is okay. Okay, letter C. What's the probability that he wins? Probability is always the number of successes or the way that something happens divided by the total. So it's going to be S over T. In this case, that's 5 over 11. So 5/11. Let's make it boxes from now on. Okay, letter D. What's the probability that Zoro wins? So Zoro winning is the same as saying Sanji loses. So that would be number of failures divided by total, which is 6 out of 11. Does not recognize my box as a box. There we go. Oh, no, it's still not. Sorry, guys. Sorry to get hung up on something that's so mundane. Here you go. Okay, next one. Number 2. If you toss a coin and then roll a 6-sided die, what's the probability of tossing a tail and then rolling a number less than 3? Okay, I'm going to show you guys this way. There's 2 different ways. First way, let's just divide our answer sheet into 2 different methods. First method I'm going to show you is if we just use the fact that we have 2 things happening and they're independent of each other. How do we know they're independent? Well, because these are 2 separate events, right? Tossing the coin is not going to affect the probability of rolling the die. So we have independence, and when we have independence, and we have this special formula, which is the probability of A and B happening, is just the probability of A times the probability of B. And in general, it's probability of B times B given A, right? The second half. But in this case, because they're independent, I don't have to worry about the given A part because it's not affected. What's the probability of A? In other words, what's the probability of tossing a tail? Tossing a tail is 1/2. And then probability of B, which should be rolling less than 3. Well, there's 2 numbers that are less than 3 out of 6 total possibilities. So it's a half times 2/6, which is 2/12. And you can just leave your answer like that. I'm totally fine with that. Or if you'd like to reduce, that would be 1 out of 6. Yeah, so there's your two acceptable answers. Okay, what's the second way? The second way is to just think of it from the perspective of chapter 13.1. Just now, this perspective over here, this was 13.4. But if you think about it from the perspective of 13.1, you don't need all that machinery. You can just think of what happens. So if you toss a coin, first of all, you could either get a head or you could get a tail, right? If you get a head, what could happen? You could get a 1, 2, 3, 4, 5, or 6. Okay, I did that very ugly. Let's try this again. I could get a 1, 2, 3, 4, 5, or 6. The same thing if I toss a tail, I could get a 1, 2, 3, 4, 5, or 6. Let's just draw the little branches to the different outcomes. So altogether, we see that there's 12 different outcomes that could happen. And amongst those options, which ones end with me tossing a tail and then rolling a number less than 3? Let's circle the answers. So tossing a tail, right? And then rolling a 1 or rolling a 2. Those are the two outcomes where I toss the tail and roll something less than 3. So 2 of the total of 12 possible outcomes. So 2/12. And see how we got the same exact answer, yeah? Or if you reduce 1/6. All right, number 3. If you toss the coin 11 times, what's the probability that you toss exactly 3 heads and 8 tails? Oh, interesting question, interesting question. So if you toss the coin 11 times, first of all, what is the number of outcomes possible? This is an FCP question, fundamental accounting principle question. You have 2 outcomes possible per toss, and since you did 11 times, it's 2 to the 11th. That's the denominator, right? The total number of possible outcomes. What about the number of ways that you can toss exactly 3 heads and 8 tails? That's also a counting question, actually, which is why it's here. It belongs in the 12 and 13 chapter because we learn how to count and we're using counting to do probability. But what is that? What is that number? How do you get 3 heads and 8 tails? Well, think about it this way. It's actually an NCR question. And what is the N? What is the R? Well, N is the total number of tosses in this case. And from those 11 tosses, you're choosing 3 of them to be the heads. So right here, that's your probability. NCR with the 11 and a 3 and 2 to the 11th. If you plug those numbers in, you're going to get 165. That's NCR 11, 3, or 11 choose 3. And 2 to the 11th is 2048. And you can't reduce that any further because 165 is not even, and 2048 is only divisible by 2s. So that's your answer right there. And yeah, this applies. Oh yeah, no, another thing. See, people often ask me about this particular question is, what happened to the 8 tails? Where does that appear? Well, the answer is once you pick the 3 heads, the 8 tails kind of just slot themselves in automatically, right? Once you decide where the heads are going to happen, then the tails have no place to go. I mean, no choice but to just go in the other tosses. So if you wanted to, you could have done this problem from the perspective of the 8 tails instead, but not both. You choose one or the other. So if you had said 11, choose 8, choose the spots for the 8 tails, that means the heads are going to be decided automatically instead, right? And you would have gotten the exact same answer. So you can do one or the other, but don't do both. And because I don't want you guys to get confused and think that you have to do both, I'm actually going to erase what I just wrote there and recommend you just stick to the first one. Okay, I'm going to do another page and then we'll take a break. Number 4, how many ways can you rearrange the word COVID? There's 1, 2, 3, 4, 5 letters and they're all distinct. So it's a simple counting question. It's just 5 factorial. And what is 5 factorial? It's 120. So 120 ways. Small side note here, guys. If you prefer to use the NPR, you're not wrong. You could do from the 5, permute all 5, and you would have gotten the same thing. So alternative method to find the same answer. All right, number 5 says, at McDonald's, a Happy Meal has the following options. Hamburger, 4-piece chicken nugget, or 3-piece chicken nuggets. I'm sorry, 6-piece. I can't read. I was thinking the number of options that equates to. So hamburgers 1, 4-piece, 6-piece. Those are 3 different options, right? That's 3. Fries or apples for the sides. That's 2 different options. The milk, water, juice, chocolate milk. This is 4 options. So how many unique Happy Meals? I think this is actually, I think this is an actual menu, I think, from McDonald's. This is 3 times 2 times 4, which is the FCP, and it's 3 times 2, 6 times 4 is 24. So 24 meals. I should say Happy Meals, but whatever. Okay, number 6. If you draw a card at random from a normal deck, what's the probability of drawing a club or an ace? We've seen this question several times already in different forms. So a suit and a particular card, right? Well, the standard way to do this is to use the formula of A union B, which is the probability of the first plus the probability of the second, and then minus the probability that they both happen. Right, in this case, probability of choosing a club is 13 out of 52. There's 13 clubs out of 52 cards. Probability of an ace is 4 out of 52. And then subtract the intersection probability, which is 1 out of 52. That's the probability that you have a card that's an ace and a club, which is the club of the ace of clubs. I mean, right? So 13 plus 4 minus 1 is 16 out of 52. You could leave your answer like that, or you could reduce it to 4/13. Either way is correct. Let's make that 3 a little nicer. Okay, last one on the page, and last one before we hit our first break. So we've got probabilities here. We've got probability C, probability D, probability D given C, and we're asked what's the probability of C and D. Well, the first thing to note is we have the general formula for this, right? In the notes that you have it as A intersect B, but, oh, sorry, I wrote the wrong letter just now. I meant to write D here. So in your notes, you have A intersect B, right? But who cares what letters you pick? Just follow the format of the formula. You've got something on the left, you've got something on the right. What does the formula say? Well, it says you take, if you want the probability of something and something, it's the probability of the first thing times the probability of the second thing given that the first has happened. So right there you got it. And if you look, oh, we already know those numbers, right? We know probability of C right there. We know probability of D given C right there. So we just fill in those numbers. That's 0.8 times 0.5, and that's equal to 0.4. All right, so that's the answer right there for part A. Now, once you have part A, then moving on to part B, pretty simple. We're again just going to use the formula here. Probability of something or something is probability of the first thing plus the probability of the second thing, but minus the probability of their intersection. But oh, look, I know those three things. Let's use a highlighter this time. Probability C, that's right there. Probability of D, that's right there. And probability of C and D, we just finished figuring that out, right? There it is. Okay, so I just got to fill in those numbers and work it out. Probability of C was 0.8. Probability of D is 0.3. And probability of C and D is 0.4. So 0.8 plus 0.3 minus 0.4, that's 0.7. So there it is. All right, guys. See you in the next video.